it's self-maintenance. It maintains above combustion threshold temperatures, which induce the convection, which vaporize the wax in the wick, on and on. It's actually self-maintenance in quite a number of ways. Now here's a side comment. One of the things we're concerned with in these sessions is differences among some of the approaches. And I would point out that this notion of self-maintenance, at least, is not the same thing as autopoiesis. Autopoiesis is supposed to be the self-construction of constituents, and that's obviously critically important. And it's generally recognized that that's not going to happen unless you have a far from equilibrium condition going on. But self-construction of constituents is a form of self-organization. And in this terminology, it's not a form of self-maintenance because there is no relationship back to the maintaining of the far from equilibrium conditions that are the conditions for the self-organization. And self-maintenance, as I'm trying to define it, depends exactly on the system being able to influence the environment so that the environment can maintain the system. So far from equilibrium conditions alone can yield self-organization, but alone they do not yield self-maintenance. A further specialization is recursive self-maintenance. Candle flames, they're self-maintenance, but they're not recursively self-maintenance, and I'll explain a little bit more what that means. If the candle flame is running out of wax, it's out of luck. It can't do anything different. A bacterium, a Donald Campbell bacterium, in contrast, can swim, and if it finds itself going up a sugar gradient, it will tend to continue swimming. That's self-maintenance, notice. It's getting more and more food. But if it finds itself going down a sugar gradient, it will tend to stop and tumble. So it'll reorient in a semi-random way, and then it'll start swimming again. If it's still going down the sugar gradient, it'll tumble again until eventually it's going up the sugar gradient. So notice, swimming is self-maintenance if it's oriented up the sugar gradient. It is not self-maintenance. It's negatively self-maintenance in some sense if it's going down the sugar gradient. And the bacterium can detect the difference between these two conditions and adjust what it does accordingly. So it maintains the condition of being self-maintenance. It self-maintains the condition of being self-maintenance. And in that sense, it is recursively self-maintenance. Actually, the real bacteria are smarter than this, but this illustrates the point quite well. You can fool real bacteria because just like you or me, they'll go up a saccharin gradient, which is not self-maintenance, it's a mistake. They can also respond to noxious gradients and all kinds of other stuff. They're brilliant. This simple model illustrates. Well, okay, this with further complexities yields the notion of autonomy, which is a common word in some of these fields. But it's an active notion, it's a relational notion, an interactive notion. It requires interaction, not just existing within a far from equilibrium environment. It does not yield a notion of independence. It rather yields a notion of being able to make use of the environment in order to self-maintain. So it's more a notion of capabilities or powers or something like that than it is independence. What about normative emergence? Well, I've already kind of hinted at that. I talked about the sense in which the swimming contributes to self-maintenance. In that sense, it's functional. It's functional for the continuation of the bacterium. And if it's swimming up a sugar gradient, that's dysfunctional. That's a normative sense of function. This is a sense of serving functions. And that gets me into its own entire literature, which I probably shouldn't try to get into unless people want to ask about it. But what I would suggest is it is a normative sense of function in the sense that function normatively is either a contribution to or a detraction from the ability of something to persist. This ability, as I pointed out, is active and interactive. It requires interaction, not just reception of far from equilibrium thermodynamic conditions. It gives us a notion of agency, and let me say a little bit more about agency. Any complicated agent, any animal, has to have indications of the possibilities of what it could do. Because it can't do everything. I can't open the refrigerator here because there isn't any refrigerator. And hopefully I know that. Hopefully my indications of what I can do and what I can't do are accurate. Notice, they might not be. They can be wrong. They can be in error. But anyway, I've got to have them. I mean, the frog has to have indications that it could flick its tongue here and eat, and flick its tongue here and eat, and no indication that it could flick its tongue here and eat because there's no dot, there's no fly or anything. All the way down through the phylogenetic organization, any agent has to have indications of what it can do, and it has to select among them. And it may select among them, a triggering relationship, it may select among them in terms of some goal, maybe it's hungry, who knows what. I mean, in the case of the frog, maybe it's hungry, but a shadow of a hawk comes over. It better jump in the water rather than trying to eat. So this selection process, I would suggest, can get itself very, very complicated, and the general domain of the study of these selection processes of what to do next constitutes the field of motivation. But what is being selected among are these indications of action and interaction potentialities. And as I pointed out, those can be true or they can be false. I could falsely indicate the possibility of opening the refrigerator here. They have truth value. Now, here I'm taking what in some circles is a very heretical stance, and I'm arguing for representing. And the basis for this is that, so I argue, truth value is the fundamental property of representing, not correspondence. I am one of the strong arguers against any kind of correspondence model of representation. But even though you don't have correspondence, these anticipations of what you could do have truth value. And that, I argue, is the ground, is the foundation, is the fundamental constitution of representing. And notice this is an action model of representing, and it is in fact quite consistent with Piaget. And in fact, I steal shamelessly from Piaget for examples. So, what is a little object from an action perspective? A little object is a thing you can manipulate, you can do visual scans, and all the different manipulations and visual scans that are possible form a kind of a network, so that from any point in it, you can reach any other point. If I have this visual scan, I can always get this other one by manipulating it and turning it around. So there's a kind of closure within the network of possible interactions. That's just Piaget, 1954, translated into this language that I'm using. Representing, by some people, is sort of treated as a psychological version of phlogiston. We think we're talking about something real when we talk about representing, but there's not really anything there. And in the sense of correspondence, I tend to agree, but in the sense of truth value, I'm arguing, and I'm just sort of giving you an argument. I disagree. There are things that bear truth values. Another comparison, another connection here is with the Gibsonian notion of affordance. The notion of affordance sounds enormously like this idea of indications of potential interactions. And at a sufficiently general level, it is. They converge almost entirely. But as soon as you start getting specific about it, people don't want to go with me where I go with it. So, for example, they don't want to admit there is any truth value there. Some people want to treat affordance as a purely factual relationship. That gives you troubles, however. Yeah, there could be a sense of affordance that's purely factual, like it is an affordance to me right now to construct a particle accelerator right here and detect electrons and nuclei of atoms or something like that. And that would have been an affordance in a strictly factual sense 10,000 years ago. But that strictly factual sense of an affordance is kind of useless, because you've got to have the actual indications of an affordance in order for it to be relevant to psychological phenomena. And as soon as you've got indications, number one, you're talking about something in the brain, and number two, it starts sounding like representation. And some people don't want to go there. Especially when you start talking about organizations like of a little toy wooden block for a kid. Organizations of indications of potential interactions start sounding too much like representation. So yeah, the sort of core intuition of an affordance, I think, converges very strongly, or at least indications of affordances converge very strongly with these notions. But acknowledging that they have truth value and that they can participate in enormously complex organizations goes beyond what most people want to do with affordances. Okay, this forces a constructivism. If this is the nature of representation, it forces a constructivism. There's no passive mind here. There are no signet rings in wax, there's no blank slates, there's no transduction, there's no induction. Constructivism can be added ad hoc on top of a base of atoms or something like that. But what are the atoms? Where do they come from? How do they emerge? Fodor has an argument that they can't emerge, and therefore they have to be innate. But in order to be innate, they have to have emerged, because they have to have emerged in evolution. And there's a contradiction in Fodor's argument there that nobody ever pays much attention to. There's a paper by Jed Allen and myself, Stepping Off the Pendulum, that analyzes how this particular dialectical problem plays out within the quote empiricist, quote nativist debate in infant and toddler development. Both sides of this debate, so we argue, are making an underlying mistake that is in common to both of them. So they're both making the same mistake, but in different ways. And the title, Stepping Off the Pendulum, is in effect saying, look, we're just going to swing back and forth between empiricism and nativism over and over and over again, unless we can actually get off the whole process. And the only way to get off of it is to avoid this fundamental mistake that they both make. Well, an agency, a system construction in an agent has to be constructed. It cannot be impressed by the environment into a passive mind. No signet ring can impress a successful agent organization. So we have to have construction. And absent prescience, we got to have an evolutionary epistemology. There have to be trials and errors. There have to be things that we try out, constructions that maybe work, constructions that don't work, some sort of variation in the selection process. An evolutionary epistemology precisely in the Donald Campbell sense. These constructions will occur via self-organization and other more complicated constructivist processes. So, a constructivism is forced, but within the framework of constructivisms, there are even richer possibilities. Not all agents have these richer possibilities. All agents do have to have some sort of constructivism. But the constructivism, for example, could be you've got a base that the worm originates with, and all the constructions are variations within that base, maybe variations in synaptic strength within C elegans or something like that. Recursive constructivism is a kind of constructivism in which prior constructions can serve as the framework or the base for further constructions. They can serve as the base for further constructions either in the sense of serving as units in the further constructions or serving as loci for variations within the previous constructions. And notice Piaget's model is recursive. Previous constructions serve quite importantly in Piaget's model for later constructions. Another one that might be distinguished is what might be called meta-recursive constructivism, and that simply means that the constructed processes themselves undergo some sort of evolutionary epistemology. And it seems, once that's pointed out, that that's true about you and me, and maybe about some other complicated organisms. It is not clear to me that Piaget's model was explicitly meta-recursive. Equilibration seems to be equilibration is equilibration all the way through. Equilibration can be recursive, but I, in my own minimal Piaget scholarship, have not found any hints that he thought about meta-recursive. Well, okay, so we've now got a constructive model, we've got a recursive, we've got a meta-recursive constructive model. Let's suppose we look at the dynamics of these constructions, of these generation of variations and the kinds of selections that occur on them. They don't work, the anticipations don't work. I don't know how smart frogs are, but one of the classic examples in the philosophical literature, at least, is the fact that frogs will not only flick their tongue at flies, they will also tend to flick their tongues at pebbles that some evil botanist has tossed in front of them. I have never seen a discussion of whether flies are smart enough to eventually learn to distinguish between pebbles and flies and stop flicking their tongue. But it is at least conceivable that they could be. I don't know. But the study of that would be the study of learning. Now, these learning processes take place. Notice this is not associationism, et cetera, et cetera. The study of these kinds of learning processes, especially in a recursive constructivism and a meta-recursive constructivism, immediately encounter issue of some constructions preparing for others, or some constructions making others more difficult, or something like that. You've got constraints on trajectories of construction. We've got precursors, prerequisites, enabling relationships, all kinds of stuff. And what I would suggest is that the study of development is the study of these properties of the potential developmental space. The constraints, the enablings, the precursor relationships, etc. I won't have time to do it, but one of the things this yields is a model of scaffolding that permits the notion of self-scaffolding, which is kind of interesting because within standard models of scaffolding, self-scaffolding sounds internally contradictory. One kind of constraint on these constructions is the constraint of the number of reflections, what I call knowing levels. If you've got a system interacting with the environment and some other system that can interact with the first one, and maybe some other system now that can interact with the second one, notice it's not possible to have a construction at level n without there already being something at level n minus 1 to interact with. You have an ontologically forced sequence. Now, it's not a full structural stage sequence in the Piagetian sense, but it is something like a reflective abstraction sequence. And more details to be said here, but I have argued that there is an onset of this ability to go to a second level at about age 3.5 to 4. This enables lots of other constructions that would otherwise not be possible. And there are some empirical results that seem to lend support to this. There seems to be a fundamental shift in every domain study that I've ever looked at about age 3.5 to 4 that seems to be explicable in these terms. And one that I predicted myself. And here's the one I predicted myself. Suppose you take a wooden block and you hold it at an angle on the floor and you ask, okay, what happens if I let go? And they'll say it'll fall, and you let go and it falls. And then you hold another one and you say, what happens if I let this one go? They'll say it'll fall, and you let go and it falls. But now you hold two of them together and you say, what happens if I let go? The reasoning here is that without this second level, they can function in the world in a Piagetian sense that presupposes object permanence, but they cannot actively reflect on objects per se, and therefore they cannot actively reflect on the relationships between objects. That was the reason. So, they should not be able to, in any consistent sense, realize that the blocks are going to prop each other up. And sure enough, at about 3.5, kids normally say, well, they'll fall. And then when you let go and they don't fall, they'll say, oh, well, the floor's holding them up. They don't seem to get the relational interaction there. There's a paper by Jed Allen who did this study recently. Actually, a graduate student friend of mine did this study in the early 1970s, and he never published it, and I sometimes want to shoot him. But Jed and I did it, and it worked in the early 70s as well. Okay, second to the last point. I promised to say something about brain processes. So here goes. This is going to be kind of quick. All I want to do is to illustrate that you can, in fact, address these kinds of issues within the framework of what we know about the brain. When you're looking at dynamic systems, systems that modulate each other, they're all ongoing all the time because they're processes, they're intrinsically processed. A neuron is intrinsically a process, and the other neuron is intrinsically a process. So the modulation from one neuron to another is not causal, although we use the word cause for it, but notice there's no conservation of energy. The influence from one neuron to another, even if it's just a switch, releases a whole lot more energy than is transferred. It's not a billiard ball hitting another billiard ball. So when we've got dynamic systems, what is the equivalent of one thing hitting another? Well, it's one thing modulating another. And in dynamic systems terminology, that's parameter setting. So one dynamic system can set parameters for another dynamic system. Changing the parameters in a dynamic system can change the organization of the state space within which it moves, back to Paul's talk the other day. Well, in the brain, we have many, many examples of exactly this, and I want to focus on one. In particular, say in the cortex, in a little piece of the cortex, we've got large-scale processes that are relatively slow. They're relatively slow precisely because they're large scale. They involve chemical diffusion, and since it's over large scales, it takes more time. We also have very small, fast processes, like classical synapses. It's also diffusion, but it's diffusion just across a synaptic cleft. So it's much faster. And we have lots of other examples. We have gap junctions between neurons that don't involve any transmitter substance. They're just direct exchange of ions between neurons. There are volume transmitters that diffuse throughout the intercellular space. There's astrocytes that do all kinds of stuff. They have receptors for neurotransmitters. They emit neurotransmitters. The astrocytes have gap junctions with each other. The astrocytes modulate neurogenesis. They modulate synaptogenesis. I can go on and on and on. We have many, many kinds of processes at multiple, both physical and temporal scales, and they're modulating each other. They're setting parameters for each other. Well, if we sort of oversimplify this and just look at the large, slow processes and the small, fast processes, the large ones are setting up parameters for the fast ones, and the parameters set up the dynamic space within which the fast ones occur. In particular, one very interesting way in which they can do this is that they can induce various attractor landscapes. So we not only have dynamics occurring within attractors. Remember, attractors are a space of the dynamics in which, as long as you're in an attractor basin, what's called an attractor basin, you'll tend to go to the attractor. Maybe it's a point attractor, maybe it's a cyclic attractor, different kinds of attractors. There's interesting evidence that, in fact, the brain works that way. It does not work by sending little partial action signals down the neurons. It rather sets up the dynamic space, including attractors, for other parts of the nervous system, like how we walk. We walk not because there are little robot signals coming down from motor cortex, but rather because there are dynamic processes in the spinal cord that can A, get released, and that can have their dynamic spaces altered such that a cyclic attractor in there makes the pendula of our legs swing in the right way so we end up walking. So these slower processes set up attractor landscapes and they modify. So now we have a dynamics of attractor landscapes which frame the dynamics of the smaller, faster processes. Walter Freeman in California has talked a lot about attractor landscapes, and he even talks about modifying them, but he only talks about modifying them as a result of learning. I think he's quite right about that, but I'm talking about dynamics of attractor landscapes that are ongoing in real time. This modification of dynamic spaces is the dynamic space equivalent of programming. But there's no instructions. It's rather framing and organizing the structure of the space within which the dynamics is ongoingly occurring all by itself. Notice if we set up a dynamic space, that's anticipatory. If we set up a dynamic space, that's anticipating that the dynamic space is going to work. That the actual dynamics is going to be one that is appropriate to that space, that's going to stay in the space, and there we have truth value. There we have the anticipations that I argued for earlier on sort of philosophical theoretical grounds, and now we find that what we know about how the brain works gives us the same kind of conclusion. I would point out that the functional relationships in the brain, like synapses, are approximately steady state. They are not hardwired. They are maintained in an approximate steady state, which means they're always variable. So if we've got a destabilization of this maintenance, this steady state maintenance, with failure of anticipation, and a stabilization with successive anticipation, we have an evolutionary epistemology. And that, in fact, seems to be the way the brain works, all the way down, again, to C.L. Dawes. It takes a lot of work to figure out how that can handle the kind of things going on in your brain and my brain, but I would argue that this is the fundamental phenomenon. Well, this is just a truncated little slice through things. There are many, many further emergences. Reason, rationality, science. Emotion, very interesting. It doesn't seem to be handleable with any sort of information processing framework, and I would argue that, in fact, emotion cannot be handled that way. And then there are even further levels of important emergence: social ontology, language, persons, personality, psychopathology, ethics. I'm working on an ethics discussion right now. But I'm not going to get into those right now because I'm already out of time. So, conclusion: the process metaphysics yields ontological emergences, including in particular normative emergences. Mentality and personhood are absolutely saturated with multifarious normativities. Everything is normative, all the way down to basic